Today we're covering our most recent material. We'll talk about systems of equations and scatter plots. When we talk about a solution to a system of equations, it's where the two equations are equal and have the same x and y. On a graph, it's the point where the two lines intersect or where they cross. First thing we'll do is solve systems by graphing. This means we're trying to find the point where the two equations are equal. So when we graph, we need our slope and our y-intercept. Looking at this first equation, my slope is 1/2, so I'll write that. Well, actually, it's -1/2, which means it's going to go down. So now I'll explain what that means. Since the top is -1, that's going to be down 1. And then slope dude always goes to the right, so he goes right 2. Now for my y-intercept, that's a number that's by itself. My y-intercept here is 2, so I write that as 0, 2. Let's go ahead and graph this line. First thing we graph is our y-intercept. And then I do the slope from there. I'm going to go down 1, right 2, as far as I can to the right. And then I'll reverse, go back to my y-intercept, and then go up 1, left 2, as far as I can to the left. Now we need to connect those dots and make a straight line. Mine's not perfectly straight, but that'll have to do. Now for our next equation. So we do one at a time. My slope for my next equation is 3/4 because that's what's in front of x. Now let's explain what that means. Since that's a positive fraction, then slope dude needs to go up the mountain. Puff, puff, positive, up the mountain. So we're going to write that and explain what this means. He goes up 3, and then he always goes to the right. So he goes right 4. Now we'll figure out our y-intercept. My y-intercept is a number by itself, so 7. I write that as a point. Now we're ready to graph this line. First thing we do is graph our y-intercept, so 0, 7. Now we do our slope from there. We go up 3 and right 4 as far as we can. Looks like that's as far as I can go. Now I have to go back to my starting point and reverse the other way. So you'll notice at -4, 4, I actually just outlined my point again because that point was already there. Now we connect our dots and make a line. So I see at -4, 4, these lines are intersecting or crossing, so that's where their x and y are going to be the same. So my solution is going to be -4, 4, that point where they cross. Now we're going to move on to solving systems of equations by substitution, which means we're going to replace one of our variables with something else. First thing we do is circle the variable we want to replace. Remember, in this class, we are always going to replace the y. Now I set my equations equal to each other. Now we're going to solve that equation. First thing we do is subtract the 3x because I want to make sure my variables are on the same side. That'll cancel out. And I'm left with x, bring down the 15, plus 15 equals 17. Now to get rid of that plus 15, I subtract. And I'm left with x is equal to 2. We're not done. We need the y value as well because we want to write our answer as a point. So I have to choose one of these equations to plug back into. It doesn't matter which one, whatever seems easier. So I'll choose 4x plus 15. Now instead of writing x, I'm going to put a 2. So 4 times 2 plus 15, which is 8 plus 15. Well, 8 plus 15 would give me 23. So y is equal to 23. We don't stop there. We make sure we write our answer as a point. So our final answer should be 2, 23. Next example, start by doing the same thing. Circle the variable you want to replace. Since they're both equal to y, that's what we're going to replace. And then I say that -3x plus 1 is equal to 7 minus 3x. Again, we'll solve this equation for x, so I add 3x to both sides. Because it's negative, I have to add. Now, -3 plus 3 equals 0, so both of those cancel out. And I bring down what I have. I'm left with 1 is equal to 7, which is not true. So we say no solutions. Now on to scatter plots. The fat content and calories of 7 different sandwiches are given below. Make a scatter plot of the data and decide if it has a positive relationship, negative relationship, or no relationship. X is going to be my fat content, and Y will be my calories. First thing we need to do is scale our graph. Let's first label. This is going to be fat on the x-axis, and the y-axis will be calories. Okay, I always put a 0 at the bottom left-hand corner. Let's start with our x's. Our smallest x value is 19. So it doesn't really make sense to do 0, 5, 15 when there's nothing there. So we're going to skip up, and we do that by drawing a little jagged line to show that we're skipping some numbers. And I think I'll start at 15 and then go up by 5s. So again, I went up by 5s. I started at 15, I ended at 55. Now for my y-axis, my smallest number is 250. So again, it doesn't make sense to do 50, 100, 150, 200 when there's nothing there. So we're going to skip up, and I'll start at 250 and then go up by 50s. So I know that's kind of messy. I started at 250, I went up by 50, so that's 250, 300, 350, all the way up to 700 is my highest number. Now I'm going to graph these points. Let's see, first one is 31, 250, so I go just a little past 30, and then I go up to 250, so right about there. I'm going to let you do the rest. This is kind of a weird looking graph, but it does appear to be positive, so let's go ahead and say that. This is positive, but it's going to have a weak correlation because when I try and draw a line here, I kind of have to put it in the middle, right around this part, but that will be a little bit weird. The points are going to be pretty far away, so I'm going to go ahead and draw my line of best fit. My line's not perfectly straight, but that'll have to do because this pen is kind of hard to write with. Here's the thing. I know that I don't have the same amount of points on both sides, but I have to put it in the middle there. Now you'll notice I put it closer to where I have most of my points. So that's going to have to do. That's probably the best line of best fit we can make. Now we're going to use the line of best fit to see how many calories would a sandwich 52 grams of fat have. So we'll use black. If I'm at 52 grams of fat, that's right over here. So I'm going to follow that up to my line and then follow it over. So that's really close to 700. Maybe it's about 690 calories. So quite a bit of calories if I have 52 grams of fat, and I did that by using my line of best fit on my graph. Last question, if the equation of the line of best fit is y equals 19 halves x plus 160, we'll use the equation to see how many calories would a sandwich with 16 grams of fat have. So we're going to plug in for x because grams of fat was my x. So let's write our equation first. Now we're going to replace x with 16. In order to get my answer for y, and y will be my calories, in order to do that, I just plug this into my calculator. So in my calculator, I'm going to do 19 halves times 16 plus 160. If I want to do 19 halves in my calculator, I do parentheses 19 divided by 2. So go ahead and type that in. Let's see, after that I type that in my calculator, I get that there is 312, and since that's y, I say 312 calories because y is what calories was. So that's my final answer.